now we're going to take our kind of understanding onto our other outcome that we talk about. So instead of talking about just about our Venn diagrams, we're talking about a little bit about conditional statements, their converse, their inverse, and their contrapositive. Our first section in that one is going to talk about conditional statements and their converse. Basically, a conditional statement is just saying, if this, then that. So we'll talk about different situations, but if I do really good on my test, my parents will be happy. The converse is just literally switching up this. All right, there we go. It's just switching up this and that. So all it's doing is just switching up what it's talking about. So in that same situation, is if my parents are happy with me, then I did good on my test or whatever. So just kind of switching up the parts of the statement. And when we talk about conditional and their converses, we also have to talk about what a biconditional statement is. And it's basically when both the conditional statement and the converse are true. Oh, my writer's been a little bit glitchy. Then what that means is that a biconditional statement is true. And the way that we write it is this, if and only if that. The way mathematics in higher kind of logic and understanding, we write a double arrow, which basically just means that both ways are true. So first example, is the following statement true? State the converse, and is it biconditional? So our first saying is, if it is not cloudy out, then it is sunny. The converse of it, actually I'm going to type these out instead of writing them. So the converse of it would basically be saying, if it is sunny out, if it is sunny, then it is not cloudy out. It's just switching up the two situations. So another question that we need to ask ourselves, are they true? Where's my pen? I'm getting a little bit of a glitch here. So sorry if I don't write the greatest here. So if it is not cloudy out, then it is sunny. Is that true? Well, you might be thinking, yes, but no, it's not true. Why? It could be nighttime. On night day or at nighttime, it doesn't have to be cloudy out. Same thing with Converse. If it is sunny, then it's not cloudy out. Well, you can still have clouds. It's not necessarily true. Oh, what the heck is going on with my pen? Yeah, it could still be cloudy out. So is the statement biconditional? Ah, my pen is really being glitchy. I'm gonna try unplugging after this lesson. The short answer, no. But it doesn't mean that both of these have to be false in order for the biconditional to be false. No, it's just one of these has to say no. Because you could make the argument, if it's sunny, then it's not cloudy. Well, like by definition, you can go by as like, You could still have clouds, or you could talk about what cloudy is. But you could make the argument that, yeah, if it's sunny, it's not really cloudy out. But because if it's not cloudy, then it's sunny. No, it could be nighttime. That just one of these being false means it's not biconditional. Alrighty. Yeah, I'm going to go and type. So first off, okay. So a person who cannot distinguish between certain colors is colorblind. Write the sentence as a conditional statement in if blank, then blank form. So if P, then Q is just saying if this, then that, which is exactly what this is. If P, then Q. So the way that we could write this is if a person cannot distinguish between certain colors, then they are colorblind. For B, we can write the converse of it. So it's just switching the statements. Oh, don't mean if. If a person is colorblind, then they cannot distinguish between certain colors. Distinguish between certain colors. I want to be Canadian and use a U, but I just want to add too many U's. Alrighty. Is this statement biconditional? So in order for something to be biconditional, both the conditional statement and the converse have to be positive. Now, just so you know, I'll mention in our next section as well, I will always ask things in a certain order. I will always ask it as conditional, then converse, then the other two. And I will always ask in that order, just so not to mess with you. Is a statement biconditional? Well, the answer is yes. Both the conditional and converse statements are true. It's actually by the it's the actual definition. And usually you only have biconditional statements if it is the actual definition. So if a person cannot distinguish between certain colors, then they're colorblind. That is the actual definition. Not distinguishing between certain colors is colorblind. Being colorblind means that you can't distinguish between certain colors. So the biconditional statement would be saying person is, or sorry, cannot distinguish between certain colors if, sorry, I'm trying to catch spells nicely, if and only if and only if they are colorblind. So that's what the biconditional statement would say. All right, take a look at this one. Considering the following conditional statement. If a whole number is divisible by 10, then its last digit is 0. Now we're talking about complete divisibility, meaning that your answer is a whole number or an integer. So is this conditional statement true or false? The whole number is divisible by 10, and its last digit is 0. So let's look at a couple examples. 0. Yeah, 0 is divisible by 10. 10, 20, 30, 40, 50, 10,360. Yeah, all of those are true. Yes, it is true. Oh, sorry. That is actually it's the common divisibility test that's used. So a whole number is divisible by 10 if the last digit is 0. Now, when we talk about last digit, we are talking about the one in the ones place. We're not talking about decimal place values. That's values, not digits. Is the converse of the statement true or false? So the question is, if a whole number's last digit is 0, then it is divisible by 10. Is that true? Whole number's last digit is 0, then it's divisible by 10. Yeah. True. Again, it's our divisibility rules. All right. That should mean that you get to have some fun.